Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing recursion topic and pattern was divide and conquer. So today we'll do the next question, which is merge sort. So as you can see the problem statement here, array has been given and we have to sort it using merge sort algorithm. So there are multiple sorting algorithms: selection sort, bubble sort, quick sort, merge sort. So in this video we are going to learn about merge sort algorithm where divide and conquer technique is being used. So technique is divide and conquer. So divide means we will break the whole array into two halves and keep on breaking it until the array size is 1. Why? Because when we will divide and at the end suppose the array says I have 10 or suppose the array say I have 5. So I can say ki any subarray of size 1 is sorted, and once I know this is sorted and this is sorted, then we will try to join this back or merge this back. That's what conquer is. So let me show you how the division will look like. First we will divide this array into two halves. So definitely if we have to divide this into two halves, we need a mid pointer, correct? And to calculate the mid pointer, we need left point and right point, correct? So if I have left point and right point, so I can calculate the mid for sure. Yes. Now here let's say my left is pointing to 0 index and my right is pointing to I think it's 10, so 9th index, correct? So I will divide this by the mid formula, and definitely the mid will be 9 plus 0 by 2, which is 4.5, means 4. So I can say we will divide this whole array into two equal half by like from left to mid and mid plus 1 to right. Okay, so this is what we are going to do. Now from left to mid this will be one part, and from mid plus 1 to right this will be another part. So once I divided, this will look like 10, 9, 8, 7, 6. That's it. And now another part will be 5, 4, 3, 2, 1. Okay. Why till 6? Because mid pointer is 4, and as per 0 base indexing 0, 1, 2, 3, 4. 4 means we have to take left part from 10 to 6 and 5 to 1 will be the right part. Okay, we have divided this into two halves, but does that mean ki this is sorted and this is sorted? No. Means the idea is very simple. Keep on dividing it until the array which you form or which we form, we can say ki it is in sorted order. And this is only possible when the subarray size will be exactly 1. So that's what we will do. So I can say ki the left pointer, like for this left is still 0, correct? But the right will be mid and not the previous right, correct? So I can say right will be 4. Similarly for this, left will be mid plus 1, can I say? Because this is the right half. Yes, so left will be 5th index and right will still be 9th index. Now again we have to break this into two half and break this into two half, correct? So initially the array size was 1. Now in the next level the array size has become 2. Again when we will divide this into two half, at the next level the array size will become 4, and so on. So how we are increasing? Is it n times linearly increasing, quadratically increasing, or exponentially increasing? It's exponentially. And how? 2 power n. So definitely from this theory we can say that we have to apply a recursion technique here for sure. Means we will divide this into two half using the recursion technique. Now let's divide this further. Why? Because we still have, like, the size is still not 1. So we will divide this into two half and this into two half. So once we will divide, again the mid will be from 0 to 4, the mid will be 2. So means from 10 to 8 will be left half and 7 to 6 will be right half. Okay, so 10, 9, 8 and then 7, 6. Similarly 5, 4, 3 and then 2, 1. Correct. Again the left and right pointer will be new. Left will be 0, right will be mid, means 2. This will be mid plus 1, means left will be 3 and right will be 4. Again this left will be 5 as it is and right will be 7, means mid. This left will be mid plus 1 8 and right will be 9. Okay, I am doing this for you, but I hope now you understood ki why we are dividing this, and definitely when from this pair we will call two functions. So in those two functions, which is recursive calls, we will send left to mid, and in this way we will send mid plus 1 to right, correct? So now we have to again repeat the same process as the size is not 1. So I am doing this fast now for you. Okay, so now this will become 10, 9 and this is 8. Again this will become 7, 6 as the size is 1. So we will stop now. Okay, again this will be 5, 4 one side and 3 one side, and this will be 2 and 1, and we will stop for it because the size is 1. But this 10, 9 and 5, 4 still has size 2. So we will break this further. Okay, so this 10, 9 will become 10 and 9 separate, correct? And similarly this 5 and 4 separate. Okay, so I can say ki at this level, like till this level, which is the last level, whatever array, subarrays I have in my separate function calls, all are having size 1. So definitely the base case will be, when can the size be 1? Can I say when my left is also pointing to the same index and right is also pointing to the same index? So the base case will be definitely ki if left is equal to right, we will return. But is it the only case? See, there might be few cases where left might cross right pointer. Okay, so left will be ahead and right will be behind. As we have already saw this in binary search and multiple algorithms, when my left crosses my right, like in palindrome check also we saw कि we can say like all the checks have been done, so now we can return. So the returning conditions are simply कि if my left is greater than or equal to R, I will say return, because now the size of the array is either 1 or nothing, means 0, correct? So now I know the base case will be if left is greater than equal to right. But this was about divide. What about conquer? Conquer means merging. So if you can see this last level and you know the recursion rule, ki if we are at this step and we have nothing to do, so once the size is 1, we will go back to our previous function, correct? But we have to merge also. Merge means we have to sort it. So while dividing though we cannot sort, but while going back we can. So once the size is 1, so returning to the main function will simply make it 10 and 9, but we want to sort it. So basically I have this and I have this. Can I say I have indexes? Yes, I have. So you have two options. You can consider these two arrays and apply the merge algorithm. I'll teach you how the merge algorithm will look like, or with the help of indexes also we can play. Why? Because this I index will say 0 here and this I index will say 0 here. But when we call from this part, means when I was here, when my left pointer was 0 and right pointer was 1, so I can go back, and also when I have this I can merge it, na? Means from left to mid and mid plus 1 to right, without having extra array, I can simply merge in the same array. What I said. Let me teach you how the merge algorithm will look like. So this is 10 I have and this is 9 I have. I am saying we'll merge this with the help of same array. So definitely as we divided this with the help of mid pointer, so I can say I point will start from left 0 and j point will start from mid plus 1, correct? Because this mid is pointing to 0th index. As you can see from 0 to 1, the size will be like 0 plus 1 divided by 2, so mid will be 0.5 means 0. So mid will still point to the same left index and right will be mid plus 1. So what we will do, how the merge algorithm will look like, ki this is small means the same array of i's is smaller or array of j's is smaller. So we say array of j is smaller, but it does not mean ki we can swap. So what we do, after sorting, whatever the array will look like, we will not do the changes in the original array as of now. We'll make a temporary array and we'll put the sorted numbers in that array. So we will make a temporary array, and what was smaller, array of j or array of I? So array of j was smaller. So here we'll put 9 and now we'll move forward. Means initially we'll make the temporary array of 0, 0 of size 2, whatever the size of array. And now we'll make a k pointer so that it will take care of ki at kth index I have to put the value. So what was smaller? 9 was smaller. So we'll move this, like we'll put this 9 here and we'll do k plus plus. And similarly, as this j, like we are done with this j index element, so we'll also do j plus plus, correct? And as of now, as my j is out of index, so whatever is there from I to mid will be kept as it is here. Okay, so this was the smaller example. So let's take the bigger example. Let's say we have 6, 7, 8 and here we have 4 and 5. Okay, but we can consider these array elements in the same array, and let's remove this, and j is pointing to this point and I is pointing to this point. But why is j is pointing to this? Because if you remember, from here only you called na 2 recursive calls. So from 0, like left to mid, you call this, and from mid plus 1 to right you call this. So mid plus 1 is nothing but my j pointer. And now what we will do, we will make a temporary new array of same size 0, 0, 0, 0 and 0. And this is a k pointer which will take care to put elements in the sorted order in temporary array. Okay, now we'll match, this is smaller or this is smaller. Obviously array of j is smaller, so whatever the value is, we will overwrite this and we will move our j pointer ahead. Again, ith pointer is smaller or jth pointer is smaller? 5, jth pointer is smaller, so we will put 5 here and again we'll move this ahead. Now this was the point I was talking about, कि when my jth index is outside, okay, so definitely I can say कि from ith to mid, because I was supposed to move till mid, I was not supposed to move till end, remember that. So I was only supposed to move from left to mid and j was supposed to move from mid plus 1 to right. Okay, so whatever the leftover elements in my I to mid indexes, all are bigger than whatever we found with the help of j pointer. So whatever it is na, 6, 7, 8, we'll just go and put. So can I write for this key while my I is less than mid? Why mid? Because I is supposed to move till mid, means equal to mid, and j is less than equal to r, correct? So we'll write ki if array of I is less than equal to array of j, ki means what if my ith value is smaller. So then in that case, in my temporary array of k plus plus, means kth index, we'll put array of I. Why? Because it is smaller or equal to, so we'll put this, correct? Else means jth index value is smaller, so in that case, in my temporary of kth index, we will put array of j and we'll do plus plus for the next iteration. Okay, and that's it. We will come out of this while loop. So what this while loop will do now, this while loop will run until my I is not out of index or j is not out of index, means until they both are lying inside their range, this will run and put every such value inside my temporary array 1. But as you can see here, j is out of index, so definitely we have nothing to compare with. So can I say from I to mid, obviously all elements are sorted because we are merging from the lower end. As you can see, we would have merged this and this, we would have made 10, like 9 and 10, and this was 8. Then only this is also sorted, this is also sorted, then only we are going to merge ahead. Now next time, so this would have become 10, 8, 9, 10 and this 6, 7. So definitely this is also sorted, this is also sorted, then only we are going to merge it. So for sure from I to mid it will be sorted, means from left to mid, and from mid plus 1 to right it will be sorted. So once we are done, means all the value from right side, so whatever there in the left side it is sorted. So we'll just put every, like pick every value and just we will keep as it is. Okay, so but until what? Until my I is less than equal to mid. So now we'll add another while, key while my I is less than is equal to mid. What we'll do, in my temporary of k plus plus, I will add array of I plus plus. That's it. But is it enough? No. Because in this case, so j has gone out of index first. But what if I was out of index first and we are still pointing to the, like j is still pointing to mid plus 1, then definitely we have to read all such values from the right side and we have to just copy in the temporary array, correct? Yes. So hence we have to write another while loop saying what if my j is less than equal to r. So definitely we want to put everything in the temporary array. But till when? Means temporary of k plus plus, we will put whatever is there in the array of j. Now we can say ki yes, my temporary array has everything sorted, means 4, 5, 6, 7 and 8. But what was my original array? Original array was 6, 7, 8, 4, 5. Temporary array is this. So what we will do? Definitely we will run the for loop from left to this point and we will put like override all this. Then I can say ki yes, I made the changes in the original array. But why we are doing so? Because the question has asked you to give, like to manipulate the same array and sort it. Okay, so that's why very important, you have to run the for loop and you have to copy this. But now the query is from where to where you want to run the for loop. Why? Because see, here too you can say from 0 to this, but is it r, means is it n minus 1th index? No. But the question is from where to where? Is it like 0 to r, 0 to mid, or what? See, this was a recursive call. So definitely for this, like from this function, you would have sent what? 0 like a left to mid and mid plus 1 to right. But for this function, the mid is right, correct? So can I say from left to right I want to merge? See, don't get confused. Definitely from left to right, this is from 0 to n minus 1. But for this recursive function, left to right, when we are saying, it means from 0 to 2 and not from 0 to 9. Okay. So for every recursive call, the left and right indexes are having different values. So we will run the for loop from 0 to r and we'll copy everything one by one here. Correct. But the difference is ki this can be 0 index value, first index value, second index value, third index value. But in the original array, it is not same. Why? See, for this call, the left pointer was 5 index and right pointer was 9 index. Correct? So you can merge this and put here, but not at 0th index. You are allowed to put 1 at this index, 2 at this index, 3 at this, 4 at this, 5 at this. So left means 5. But from temporary array to it would have been arranged like 2, 1, 2, 3, 4, 5. So from temporary array to this is 0th index, na? But in original array you can put at 5th index. So when you are iterating from left to right, you are saying from 5 to 9. But when you are copying the values from temporary, this is not 5th index, this is 0th index. So how to reach at that point? So can I say my left is pointing to 5 and I is here, and I want my I to index at 0. So what I have to do? Can I say I minus left? Yes. So basically I am saying we'll make a for loop here for int I is equal to left till I less than equal to r and I plus plus, correct? So in my original array, so I will put at I, means at left pointer. But from temp, I have to read 0th value. So that is only possible when we will subtract left. Okay. So what will happen? What is I? Let's suppose it's 5th index, like left is 5th index. So in my temp, like original array, I want to put at 5th index. But it will be 5 minus I is 5 and left is 5. So this will become 0. Next time when we'll do I plus plus, so array of I means 6. But this will be 6 minus left, which is 5. So next time it will be first index. That's what we want to do, right? Means we will read values from 0 index to last index, whatever is there, and one by one we'll put in the original array at that supposed index which was from left to right and not from 0 to right. So I hope this is clear. So that was the only code, but this was about merge algorithm. For divide, what we'll do? Definitely for division we have to write this base case, correct? But as of now the size is not 1. So definitely we have to calculate the mid index, correct? So I will calculate mid index, let's suppose left plus right by 2, and once we have calculated, suppose this is a function, main function, where we have to send array left and right index. Okay, so definitely we'll call the same recursive function with array. Left will be left but right will be mid, can I say, because the left half we want to make from left to mid and right half will be, can I say, mid plus 1? Yes, very good, to right. Now suppose I am at this line, means I have covered this. So when I would have been returned, can I say when my size was 1, 1? So I have two arrays, let's suppose like how we have here 10 and 9. So definitely I have to do something here, otherwise it will get returned back, correct? What I have to do? Definitely, what we want to do? Merge. So now whatever we have written this idea na, like merge algorithm, this was a merge algorithm we have written na, this we have to call. So we will call the merge algorithm, merge function here, and there we have to send left pointer also, mid pointer also, right pointer also. But why? Definitely because we want to, like when we want to merge, we want to run I from left to mid and j from mid plus 1 to r. So hence for the function it is very important to know what was left, what was mid and what was right. Now what is the time complexity for this? Definitely we are calling two functions recursively, but in the same nested order we are calling the merge algorithm also, correct? So this merge algorithm we are doing for how many elements or how many subarrays? I would say this is n log n, but why? See, we are merging algorithm at this level and at this level. Okay, here the only 4 elements, but in most of the cases if you see, how many elements are there? If you see, like you have to apply merge algorithm for how many elements? No matter in what call, but at a single level, how many elements? Can I say 10? Yes. Now second time also, can I say 10? Yes. And can I say for third time also it is 10? But how many times? Can I say these are n, but how many times n? Log of n, because how many levels are there? It is logarithmic of n. So log of n times we are taking n time to merge. So that is why the time complexity for merge sort algorithm is always n log n in worst case and in average case mostly. Okay. Talking about the space complexity, definitely we are taking the temporary array. So definitely the size will be O of n, which is linear. So let me show you the code for this. So here is the code what we have discussed for merge sort for dividing. First of all, the base case is what if they crossed or they are pointing to the same index, means the size is 1, so we can definitely return. Otherwise, we'll calculate the mid index and we will call this two recursive function for left subarray from left pointer to mid and for right subarray mid plus 1 to right pointer. And once we have returned, means at line number 10 I can say ki I have returned from these two calls, so I can definitely say ki I have a size of array 1, 1 or 0. So definitely now we are allowed to call the merge algorithm function so that these two arrays can be merged into sorted array. So now in the merge algorithm what we are doing, we are creating the temporary array of size right minus left plus 1. This is how we calculate the length of array, right, with the help of right and left. I hope you know that. So, and we'll initialize our I with left and I will run from left to mid and j will start from mid plus 1 and go till right pointer. K pointer will keep on tracking ki in the temporary array where we are inserting, means at what position we are inserting the values. Now we'll run this while loop until both are at valid index, or else if something left from left part, I will take care, like while loop for I, and if something left from right part, while loop from right side will take care, correct? Now after this we'll run the for loop from left to right and we'll copy everything from temporary array and we'll put in the main array. Okay, so now we can run the code and now we can submit the code as well. So this was your Java code. I hope you understood each and every line and you can write this algorithm on your own. And here is your C++ code if you are from C++ background. So if you understood this, definitely we can go in the sheet and we can mark the merge sort algorithm as done. So I hope you are following our recursion playlist, and along with that we are done with binary search, stack, array and string. And also if you would have submitted this on your own, do let me know in the comment section. And that's it, with the hope that you all would have understood. I'm expecting a like on this video and definitely a subscription if not yet subscribed. And let's meet in another video with some more interesting questions and topics. So then keep learning, take care of yourself and your family too.